All right, everybody, welcome to our SolidWorks PCB presentation. Today it's going to be done by Inji Gadala. We've also got Bruce Perkins and Mike Buckley here from Dassault Systems, and we're going to, without further delay, turn it over to them, and hope you guys enjoy the show.
Thank you.
Thank you, Lars. Just as a brief introduction, so I'm Bruce Perkins, and I am with SolidWorks. I'm the client executive with global responsibility for Google at SolidWorks, and so I'm your primary contact if you should need any assistance on all things SolidWorks. I do work very closely with your team, and I'm available at a moment's notice to come out here. I live up in San Francisco, so I'm always available to help you should you need it. So with that, I wanted to make sure you are aware. So we have Mike Buckley, who is our technical sales manager for our electrical products, including the PCB stuff. He's going to start with an overview of the agenda, and then we're going to bring Inji Gadala to you. So she's the subject matter expert for us for the PCB solutions, and we're hoping to have a good interactive session with you. We're going to have a few breaks for questions, and so feel free to gather your questions, and we'll go through them a couple of times throughout the presentation. So without further ado, let me go ahead and turn things over to Mike Buckley to describe the agenda.
Thank you, Bruce. So all I want to do is run through what you're going to be looking at today, the subject matter at hand. We tend to confuse people with our packaging names because everything starts with SolidWorks. So we're going to be talking about, not only the CAD system, how it interacts with, our electrical products, but I want to give you a sense of the packaging so that we're really talking about two things here. So for the audience, we have one product that we branded SolidWorks PCB, which is a full set of schematic design tools, and you've got component libraries, and you've got layout and routing tools in this package, and this is the heart of SolidWorks PCB. On top of that, we package in what we call a connector to SolidWorks, and this is also very much the same connector that we use for Altium as well. So we understand most of you out there are using Altium Designer, and so what we'll be talking quite a bit about is this collaboration piece between the two. So if you purchased SolidWorks PCB or had it, you would have a connector included. If you're an Altium Designer user, you would have to add this on. So that's just the difference, but they behave the same way. Also, we're going to be talking about, as part of the connector, just to define some terms. If you're on the SolidWorks side, we refer to PCB services. Just make sure you put in your head when we say that, that's the connector. If we're talking about the connector for Altium Designer, it's the connector, even though we might call it a vault. So just to try to define some terms for you so we don't confuse you. And then there's always a connectivity right there to SolidWorks. So that's the packaging of it. So you can buy PCB, you have a connector included. You can buy Altium Designer and add a connector on whenever you want. And that's that. And really what we're trying to do in the total value proposition, one of the key things that Inji will be talking about quite a bit is how to quickly and efficiently get a blank board to fit into a complex piece of geometry. And so so we're going to always question, how long does this take you to do currently? And this is part of the value proposition, the efficiency that we bring to the table, where we can literally do this in a few seconds if you're skilled at it. First time, probably a little bit longer. But and again, the whole package is the benefit of it is to reduce the amount of work you have to do, get the design revs down so you can get to revenue and market a lot faster by not having to deal with things like step files or neutral files, IDF, IDX. Try to replace that with a more efficient workflow. So with that, we'll turn it over to Ms. Inji, and away we go. Is that mine?
That's mine, yes.
Okay.
Thank you, Bruce. Thank you, Mike. Let's switch here. Nope, we're good. Thank you. Just takes a moment to, it's coming up. It's a moment. Perfect. Thank you all for joining. So Mike presented what we're having today is we have two products. SolidWorks product is a connector and a SolidWorks PCB platform. When we looked at working in conjunction with Altium to develop a connector, we looked at the challenges that exist today between electrical and mechanical teams. So what we came up with is that there are challenges between the multiple divisions. So hardware, electrical, and mechanical, there are barriers. There are very few communication. Even if the communication happens, it's through, I call it a snapshot of the moment of the design. So communication between electrical and mechanical happens through DXF. You transfer board information to get the outline into your environment, electrical environment. You place critical parts, you export a step out, and then you give it to the mechanical, they bring it in. These are challenges that are very common today between different divisions. But when we looked at it, we said we want to introduce not just a better solution, but a workflow. So we are offering today a workflow that will allow different designers in different divisions to have design intent, to have visibility to those design intent as early as possible. So one of these challenges when it comes to a workflow or a process between the multiple divisions for the engineers is the electromechanical challenges. The other one is that we have a lack of a formal design process. So you might have different groups, within your team, and they might be interested, one team might be interested in one thing, the other team might be interested in another. And then again, you're like, this is all great, but we don't have a formal process. There's not a workflow. We don't follow a procedure. And even if it breaks down, we know where to fix it, or how we can replace it. It's just pretty much we found that things are all over the place. Anybody can start anything, electrical waiting on mechanical, mechanical waiting on electrical. You have to either go chase down the electrical engineer or the mechanical. I say communication is through Outlook. Outlook is becoming part of our workflow, or Google Mail become a part of our workflow. And then last but not least, we don't have a centralized place. Everybody needs to be pointing to a common location. It seems like electrical will have a place, mechanical has another place. It's like, good luck finding things, good luck trying to, make the connection between the board and the mechanical. And again, how we've seen it with a lot of companies, that really mechanical is where everything comes together. So it's like, okay, this is the mechanical piece, I'm gonna bring in the board, I have all the, wearing goods, whatever, depends on your product, but this is where everything comes together. So we found out that we're really looking at this. It's not anymore the electrical, what he cares about. In my domain, I used to care about that teeny tiny green thing that you see, which is, to most of you will recognize, this is the PCB. So to me, as a hardware designer, or EE, that's really what I cared about. But today, this is not just what you care about. You really need to have visibility of the entire product. So it's a product that you need to be overseen or overlooking. Of course, you need to do your work and we're arming you with a software or a platform that will help you to take the barriers between the electrical and mechanical. But again, SolidWorks offer the entire ecosystem from SolidWorks Mechanical, SolidWorks PCB, and the connector for All Team Designer, and then your data management through PDM. We're leveraging what SolidWorks done very well for over the last 30 years, along with All Team Designer, and we have a seamless collaboration, integration between electrical and mechanical teams. And then we're offering a workflow or a process through PDM that will allow you or allow all the different stakeholders to access a centralized location. So it's not anymore, I'm just doing this. I'm doing this, but I would like to have visibility. I would like to talk to my mechanical counterpart and set up a workflow. This is where we're helping you. This is where we have the greatest benefit. When you look at SolidWorks, the greatest benefit comes that you have all of the different, what I call the pieces of the puzzle coming in together by offering all of these different solutions from SolidWorks. So what I'm going to be walking in the agenda for today, I'm going to walk you through your design workflow. Kind of, I talked to Monty and I get a little bit, I sent him some questions.
This guy right behind me.
Okay, Robert?
Yeah.
Okay, so Robert actually answered the questions, and not to put anybody, maybe I shouldn't set your name, but I'm going to go through a challenge that you have today. So I put together a workflow, and maybe you guys send me, does it really represent how you guys do things today? From, you know, electromechanical collaboration, data management, and I mean by data management, electrical and mechanical. And then when you go to the PCB, you have to do your design synchronization between schematic PCB. You have to source for components and procurement. Then you have to release the stuff, and then the cycle starts again. Is that pretty representable of what a cycle of your cycle? Yes, no, somehow?
Data management, that's read the files getting into CAD?
Yes. And that's what one of the things that we don't have today, and a lot of, you know, companies don't have, they don't have a centralized location for electrical and mechanical. Electrical traditionally will keep things on a local drive, network drive. We don't have we don't have a workflow. I'm actually, you know, admire a lot mechanical because they're so adamant about their workflow. We don't somehow. It's like everything is like, I still have my own library. I'm married to my project. I'm not going to leave. So that's how we tend to do things. So that's what I refer, data management of your electrical CAD. We can leverage PDM and use it as a vault to store our electrical data.
Okay, this is for PDM too?
Yes.
Okay.
Mm-hmm. Yep.
Because today, just so you know, the step file, when they want to put a board into their model, they ask for a step file. We request it as part of the package now, but otherwise the engineers would.
Exactly. You are asking for a step, and this is one of the challenges that we are solving today, and we have a solution that do not exist by anybody else. So how is it done today? And I think this image might make a lot of sense to you. That's exactly what you said. I wait for a step, or the electricals send me a step, or now I'm going to get it into my system, and then I'm going to send something, a DXF out, so they can define the board. I think this image represents what you do today. There's the mechanical side, there's the electrical side, and then we're all going into one product. At the end of the day, those two are going to get together, you know, and combine into a product. But we have a wall. There's a barrier. There's a big barrier. Is the step, the DXF, the file size, the snapshot of the moment of the design, the communication, the friction. We know it. I've done it. You've done it. You keep doing it today. Again, it's nothing wrong, but you don't have a solution. We do have today. Yes. Oh, we have a technical help online.
Yeah.
Oh, you're in it?
Yeah. I can send you the link.
What's the go link?
It's not on the Go link. It's the live stream link that I sent out. What's your?
Well, I got other good links.
No, that. So very quickly, I'm sorry, mechanical or mechanical? Robert, electrical, right? Piano, okay. And your name? Deborah. Okay. Perfect. Nice meeting you. Thank you. Electrical? Mechanical. Nice meeting you. Perfect. We have a perfect audience here. Should we get going? Monty, Lars, are we okay to move on? Robert? Yeah? Okay, perfect. Thank you. Okay. So this is what you guys said. Robert, under the spot, feedback. How do you guys exchange word at line? You get a step out. How do you guys define critical parts? ECAD typically define critical parts. Location. Okay, this is common. And again, I would imagine you guys send in the next slide, you send the step out from Ultium. Interference, we bring the step from the mechanical bracket into Ultium, as well as giving the ME to check it back. And then last but not least, how do you guys keep track of changes? It's, our track through version control, /ME part. Okay, we recognize there's definitely, just to iterate the point, everything that's happening with a step, DXF, or, verbal communication tracking into a version control system in each environment. So I'm not talking, again, mechanical, they have their own versioning, and then electrical, they have their own versioning. So what we're doing today, I'm going to show you a better way. We are going to talk about how we can get board information. So today, what you expect out a DXF that represents the board, you get the DXF into your environment, you define the board shape, and then you send it over. And then who owns the hole? Robert, who owns the hole? Mechanical or? Okay. So there are, you have to have that conversation, right? It's like, okay, we need somebody to define a hole, that hole sits, we need to communicate, that would be DXF again or a step, but we know how holes come into Ultium with a DXF, right? It's just a cut, and then you have to place the hole to define the path for that hole. So a lot of work on your end as an electrical. And again, for those mechanical, when we bring in the DXF into Ultium Designer, it's just an outline. We have to define the board shape. It does not bring in a board shape. So these are the steps in the process that I'm going to show you today. We're going to take a look on how we can communicate design intent without relying on a step or IDX or IDF or step file, without relying on any interchange format. We're going to do this seamlessly between SolidWorks Mechanical, and I'm going to use Ultium Designer since you guys have the Ultium Designer, right? Correct. So we're going to show that through the collaboration. The collaboration, and again, think of it, the collaboration and the workflow that we're offering today. We're going to take a look at component barriers. How do you guys handle placement barriers? I need to know how far I can place my components from the edge of the board. I need to know, the high profile components. Again, the critical parts, the placement, and placement barriers, we're going to communicate this seamlessly today. We're not going to do a DXF. I'm not going to put a drawing. I'm not going to hand you a drawing. I'm not going to communicate this verbally to you. It's going to be seamless between the teams. And also, we're going to look at that parts placement, defining of that placement and checking for interference and collision. We're giving you this today in your own environment to use it. So whether you're on the Ultium Designer or SolidWorks Mechanical, we're allowing you to check for interference and collision. And you can check that seamlessly. So let me go ahead and I'm going to switch. Yes. Okay. So the connector, the collaboration works today with Ultium Designer or SolidWorks PCB. So the other product that we offer, which is SolidWorks PCB, it comes in an integral part of the SolidWorks PCB is the connector. So beside, if you don't have Ultimate Designer or SolidWorks PCB, the connector will not work. So you're still going to rely on the traditional way of exporting, your design data. Doesn't mean that you cannot you cannot start that design into Ultimate Designer or SolidWorks PCB and then take it to Cadence. That's very possible. But again, we're trying to at least tackle one of the major challenges today between the electrical and mechanical team using SolidWorks Mechanical and our collaboration technology to show you that this can be done seamlessly today. So again, think of it like we're helping you to knock down one of the barriers, and you can start in Ultimate and then take that project and then continue onto Cadence. Yes.
Can I interrupt you?
Yeah, absolutely.
So this is why people ask us, we have a product in SolidWorks Are you familiar with SolidWorks? Okay, so people ask you, is this going to kill SolidWorks? For his question, he's not using all of them already partnered with. So for him, he's still got to use IDI as only the optimum exchange mechanism. So that's what I would recommend. That's what you agree.
Yes, that is correct. Yep. Okay. So we'll start, like I said, I want to show you how the effort to communicate your board outline, your holes, your placement barrier, keeping track of changes can be done today seamlessly. And again, your harder, more difficult design, you always start a design with a shape and few parts, right? You're not going to start, with your 700 parts and then boom, you have it. So maybe that's, again, helping you define a workflow that might satisfy the different, team members. We're going to start here, and then we're going to take it to do more, elaborate or more complex design. Okay, so what I'm going to do, I am going to, okay. Start here. Okay. Go back to, I just wanted to make sure that it loads fine on my machine, the main assembly, and then we will get started. It's loading. It's just, please.
What version of SolidWorks are you using?
2018. And have you guys? Yeah.
We're still mostly using 16.
Are you still in 16? How about Ultimate Designer users? What are you guys on?
17, 16.
Are you guys ready to see 18? No? You don't want to see 18?
We have it, but we don't use.
Okay, since we recommend to be on the same platform, so we always recommend with the connector and SolidWorks Mechanical, at least to be on, the same platform. That's why I'm demonstrating today with Ultimate Designer 18, Connector 18, and SolidWorks Mechanical 18, just to minimize any risk, because today I have hardware issues. And I apologize if you guys will see. Okay, perfect. Okay, so what I'm going to do, I'm going to start from the Ultimate Designer side. Based on what Robert said, the outline is defined from electrical, and then you send it over to the mechanical. Is that right? Okay, okay, this is the beauty of it. What we offer today, it's very flat. It does not matter. We're not putting a restricted workflow. The flexibility is still there. You might, some situation, you might start from the electrical. Sometimes the mechanical define it. It's completely up to you. We're giving you the freedom where you start. There's no we don't compromise your workflow. We're actually enhancing and helping you to have much more defined workflow. So you guys tell me, where do you want to start? Mechanical, electrical? Just pick. Okay, well, we'll go with Debbie. So Deborah, right? Debbie? Okay, Deborah, we're gonna go with mechanical. Okay, so here in SolidWorks Mechanical, I have the arm. This is, by the way, an orthotic medical device for those who lost. I think last time I came here, presented with this. This is a medical device for those who lost mobility due to a stroke, and it gives them back mobility to their arm. So what we have is the PCB board. I've created a sketch. This is the sketch where for the PCB. So today, what the mechanical will do, they're gonna draw, you know, that sketch, they have the sketch, they're gonna DXF it and send it to the mechanical. I'm not gonna use the DXF. What I'm gonna do, in SolidWorks Mechanical, I have the connector. That's the collaboration. This is the intelligent piece that will link the subassembly that will represent the PCB to the actual correspondent PCB in your electrical domain. I'm introducing one step, only one step to your current workflow. So what I'm gonna do, I'm gonna create a new board assembly. And notice that it says a new board assembly. This board assembly is the assembly that will represent the PCB. So here, I'm gonna create a new board. This will be for the electrical team. That's gonna be your electrical project name. So for all team designer, that's gonna be the name for the PRJ PCB. So here, I'm gonna call it, you know, MyMO. This is the project's called MyMO, but I'm gonna put it for Google X. And this is my repository. How we're handling this, there is a backend intelligence system that actually maintains the data between Ultim or SolidWorks PCB and SolidWorks Mechanical. We can have another section, you know, talk, you know, about permissions and vault and how this PCB service, there's no extra cost to SolidWorks PCB services. This is part of your connector license. From this point on, it's your SolidWorks Mechanical environment. It's gonna prompt me to save the assembly. That's the only step that I introduced you to you today, different from what you do things. So what it's doing, it's gonna prompt me to save the assembly. It's coming. Perfect. So here, I'm gonna use PDM to just save the mechanical assembly. There's nothing different than how the mechanical will do today. This is a mechanical assembly. I'm gonna point to my mechanical, I have a mechanical project. This is the name of the assembly. And what it does, that's the intelligent now of the collaboration. It's gonna create a default 10 by 10 PCB. Notice that this PCB now is represented in your feature tree. It's getting checked into PDM. It's actually being hidden, yeah, being hidden here. It got checked into PDM automatically. And then, boom, I do have a 10 by 10. That's the default board in Ultim Designer, 10 by 10 default PCB. That's my PCB, yes.
So it automatically puts it into default? There's no step to have to add?
Nope, that is it. So it's gonna create a default board and look at your feature tree. With a DXF, you're talking, excuse my term, talking with dumb data, right? There's no intelligence. I'm talking with a step, a bulk. I don't have any, elements in my feature tree here. You have a step, you have the sketch. This is just a SolidWorks assembly. So what I'm gonna do, I'm gonna define the board outline in the context of my main assembly. So for the electrical people, this is very typical, standard action in SolidWorks Mechanical. There's nothing really, complex about it. I bring in my subassembly that represent the PCB. I'm gonna make just simple mates here. Perfect. I'm gonna edit this part. I'm gonna edit the sketch for this board. I already have the sketch that I created, so I'm gonna use the convert entities to redefine the board shape from the sketch that I drew. Straightforward? Do you guys have any questions? Okay, the beauty of SolidWorks Mechanical is file associativity. I actually define the board outline or the board shape in the context of the main assembly, and because of the file associativity, it reflected the new board shape in that subassembly. Okay, this is the subassembly that I created. So now what the mechanical do, they create a DXF and they send it out to the electrical people. Nope, I'm gonna rely on that connector and I'm gonna push design data from SolidWorks Mechanical over to my electrical team. I'm gonna inform, I can leave a commenting just to inform them, hello, board, shape. And remember, it's the shape. I'm not sending an outline. I'm actually, the board shape has been defined and now they can bring it into their environment. Done. I'm gonna switch and notice. I asked you, how do you guys keep track of changes? You said it's in mechanical, which might be PDM. This is fine. But again, when I send the DXF out, it's either an email. So I keep track of the email that I send over to the elect. There's no means today to track this, right? Because it's just an email that you send out to your electrical counterpart to tell them, go grab the DXF, or it's already inserted in the email. But I cannot keep track of changes. For the electrical, and you guys tell me if I'm wrong, it's a black box, right? When you receive that DXF, it just doesn't mean any. You're going to bring it into your environment. You're going to rename it. You're going to drop it somewhere, but it comes in as a black box to you until you get it in. And the time you also save the step out to your mechanical, for the mechanical, it's also black box. So we're just dealing with black box back and forth. So here, what I'm going to do, I'm going to pull All Team Designer. And remember, the project has been created. That one extra step for the mechanical is that they created the project, they created the electrical project. So I'm gonna open that managed project. Notice that we immediately still give you the flexibility, but in much more controlled environment, because that electrical project that has been created is already under version control and it's in a vault. So the project is managed. It's already, I'm not allowing anybody to start any project without being under version control. So that's what we say. We're actually helping you to define a workflow and to work in a much more controlled environment. It's not like anybody can start what we call an ultimate regular project, and I refer to it as naked project because it's not under version control or any means of, versioning system. So here, the project name, so my MIMO for Google X, I'm going to go ahead and open that project. Notice how it's already coming. The collaboration technology has a built-in version control system. So now the project has been created. This is your typical. Notice that I'm checking it directly into PDM, because when we work with a version control system, you have a working local repository. And that local repository can be a folder in PDM. So not only that I'm allowing you to work in a managed environment, but I'm actually leveraging one of the tools that you have today without having to go purchase an extra tool to manage your electrical data. I can manage my electrical data in PDM, and I can set up a PDM workflow. That's what I've done. I set up a workflow in PDM, and I checked in my project, my schematic, my libraries directly to PDM. So every time I create a new schematic and PCB, they're going to get checked into PDM.
Is that on the Altium side?
We're making that connection with the connector, which is a software. It's collaboration technology that we developed in conjunction with Altium that allows for the collaboration. So from SolidWorks, the connector, or we refer to as the collaboration technology, allows for this to happen. But without the connector, you cannot use. You can use it. You can just take your data into PDM, but you're not going to take advantage of the collaboration between SolidWorks and Altium Designer. So what I'm going to do now, I'm going to add the schematic and I'm going to add the PCB. Just again, standard for the mechanical. This is what we do every day. Schematic sheet for the logical circuit design, and then PCB for the physical layout and place and route. I'm going to add the PCB document to my project, and then I'm going to have to save my document. So I'm going to save it. Okay, so let me save my document first. And here, I'm also going to save it in PDM. You can, if you have this, then you will start from the Ultimate Designer. If you want to maintain all your parameters and your templates and everything, start from the Ultimate side. It's going to create a default 10 by 10, send it over. They use the same steps and send it you back. That's what I said. It's flexible. Even with your existing Ultimate Designer regular project, with a connector, you can convert those to managed. So very flexible. Like I said, we don't compromise your existing workflow. We're actually trying to help you define a better workflow. So I'm going to save the PCB. I'm not going to just save it right now. And here's the power of collaboration. I get immediate notification with a connector. And not only that, it tells me who did the change. I signed in every single user who are going to collaborate, electrical or mechanical. They're going to have their own credentials because we can track who did what and when. So I was signed into the mechanical side as a John. That's my name, John MCAD. And John, I can see he defined the board shape. No more surprises or guessing on how this board shape looks like. I'm going to hit View Changes. And I'm going to highlight the new change. I'm not going to accept, but I'm going to highlight it. Wow, I get a magenta color flashing that newly proposed board shape, the board shape. I'm not talking an outline. I'm talking the board shape. I'm going to go ahead and accept. Bam, it redefines my board shape. Back to the 2D mode. This takes us up to 5 minutes. And again, I've been using Altium for 12 years. It takes me 5 minutes to get just the DXF, and I have the video and I can play it and it shows side by side. 5 minutes just to get the DXF, reposition it, define the board shape, put the dimension, make sure. Because again, when we receive a DXF, just for those who do not know, we have to deal with scaling and units. I do not know what the scale and I do not know the units, so it's a trial and error until I get it right. Then I have to, it's just an outline, then I have to define the board shape from the outline. It takes about 5 minutes. Not drawing it, that's with a DXF. Good luck if I'm gonna draw this in Altium Designer. It can take me up to like 4 hours because the tool is not meant to draw arcs, and it's not. We know it's not. So it can be very, very painful to draw this in Altium Designer if I don't have a DXF. But you saw with the connector, it was literally a push of a button. Just say accept. You can even preview it. If I don't accept it, I don't have to. I can reject it and send it back to the mechanical. It's okay. But of course, you know, they define the board outline. Can I redefine it here? Absolutely. This is your environment. You can redefine the board outline. You can place whatever you want. And this is what we're going to look at next. Parts placement, right? We said, and Robert said, okay, holes for heat sink, we own it. If it's, you know, other mounting holes, they own it. Again, can I place a hole? Absolutely. You can place your mounting holes here and, you know, collaborate this. I'm going to start first with parts placement, and then I'm going to come back to holes and placement barrier. So I'm going to come back here to my schematic. And what we do things is we drop a component in the schematic, and then what we call the engineering change order handles to transfer the physical PCB footprint to the PCB environment. So I'm going to use my libraries. I have a predefined components. I'm going to go ahead and use one of my component here from the library. I need to look at. I'm going to grab my couple of my connectors here. And I'm going to grab another one. And what you see, again, just for those who do not know, that's the symbol representation. This is the PCB, this is the 2D view. This is the physical part that goes on the PCB. And then we also have the 3D representation. So we can embed step files. Today, to have that nice representation, because Altium Designer is a 3D aware platform. So you can embed a step file and it gives you that nice, representation of the board, and you can run your component clearance checking. But with a connector, you not just get this step, you actually get native solid part. So I can embed solid part and I can embed parasolid. In addition to step file, you can keep your generic models if you have. But the beauty of it that it actually helps reducing your file size. We know how big a file can get with embedding step files. They tend to get very large as I start embedding a lot of step. But now, since you're dealing with native solid part, having the connector, it reduces that file size and you don't have to deal with large, parts, and actually enhances that when we push it back over to the mechanical team because it deals with native solid model. I'm gonna place that second connector here. So I have two connectors. I'm gonna say this is really, at this point, these are the parts that I care about today, just with respect to placement. There is a lot, maybe other things, LEDs, but I'm going to start with just the two connectors to illustrate my point. Okay. I just want to, I'm going to use the annotate. Just let's assign reference designator to my components. So each have a unique reference designator. So I have J1, J2. Now I'm going to use the engineering change order to update the PCB with those components. Green check mark is always good. It means that now the footprint has been, I'm going to delete the room. I don't need it. I'm just going to place, again, I might not know the position of these, or maybe I know where they're going to go, and then the mechanical will really have to create their mates and lock it down. I'm going to bring it inside the board. I'm going to say I don't really know. Mechanical are ahead of the game. They know, they have the enclosure. They know where things needs to be. I'm going to leave it at this. I'm going to switch to the 3D. You get the nice representation of the two connectors because I have native solid parts embedded to that footprint. I placed J1 and J2. I'm going to communicate this back to my mechanical. You guys said I sent a step, right? So it's another black box that goes over to the mechanical. Nope. I am going to push this information to my mechanical and saying I placed J1 and J2. You don't have to leave comments. I like to leave comments so we can track, we can see the history. J1, please position. And I'm going to post. This is taking time, just a little bit of time, but because, again, I apologize, my system is, I'm having troubles with my system, but literally that takes, it's like instantaneous change. It posted this, you're ready. So let's look on the mechanical side. So mechanical, I'm gonna put my mechanical hat, I'm working. The moment the assembly falls out of sync with its correspondent PCB and somebody made a change and posted, I got immediate notification. So you see the connector panel comes with the changes. And I see, oh, Alan, this is my counterpart on the electrical side. Alan said that there are changes. Oh, okay, they position J1 and J2. Okay, let's take a look at this. If I highlight on the change, it's gonna flash. Oh, I got the new proposed, that magenta color flashing. Here's that new connector that Alan put in the PCB. And I can do the same thing with the board outline. It actually wants to change the color because in Altium, the PCB, it's the mask is green. And by the way, PCB don't have to be green. Okay, but by default, we just put, the common green mask, but you can have it blue, red, whatever color you want. But that's what it wants to change. Here it was created gray. Then it wants to change that to reflect the color of the mask layer in Altium Designer for green. I'm gonna go ahead and I can check them all, or I can check one each at a time. So it's like not all or nothing. You have the control on what you want to bring over to your mechanical environment. Just for the sake of it, I'm gonna bring everything. Sure? Okay, you will notice that we're dealing now with solid part. This is your environment mechanical. this is going to build in your feature tree as if it was created in SolidWorks Mechanical to start with. This is my part in the feature tree. Okay, almost done here. Okay, perfect. It's done. Let me stretch my feature tree. Hallelujah. I can see reference designator. I know what they're talking about now. If I stretch my feature tree, this is a solid part. I get so excited because we know the pain when we receive step file. I can't tell what from what. This is again, 2 parts, but imagine when you deal with 700 components. And then one tiny change is done to a connector. It's like, which one? You might have missed it. And then it costs an issue. And then you have to rev your board. And then we have to go through the cycle again. I've done it myself, right? But now I see it. I'm like, in mechanical, this is a part in SolidWorks Mechanical. It's in your feature tree. I can go ahead and open the part. I can see the reference designator. What am I going to do now? As a mechanical, I like to set up all my mates. I want to, reposition the component. So now I'm going to go ahead and reposition this component. So I'm going to grab it. I know this is going to go here. And by the way, it mates, the connector mates automatically to the board. That's part of the intelligent, so it's not going to be sitting free in the Z space. I'm going to drag this guy. I'm going to position it here. Okay, I think I positioned these 2 parts. Perfect. I can keep working on my assembly, but I want to instruct my electrical that I've already, made the placement for those. So I'm going to tell him position.
Do mounting holes and pads automatically follow?
Yes. Yep. Yes, in 2018, they do. But it used to follow after another, but now we make it dynamic. There are settings, yeah, position, and then we can speak the same language. J1, I'm gonna inform him it was J1 and J2. I know what J1 is, and I know what J2 is, and I have those in my feature tree. And I'm gonna go ahead and post. Yes, and I'm sorry, I did not get your name.
George.
George, yes. Here are the settings in SolidWorks Mechanical. So now we have the settings to have it dynamic, or again, depends on how you want to move those holes.
Is it faster?
Yes, that's exactly. I ask for this. They first give the option on all. I'm like, no, but you know what? Give me the flexibility, because sometimes we're moving, so it's still not the 90% done. We're still in 50, that middle stage. I want to get things done. I don't want it to rebuild. Just get it so we can turn it off, and then it will build in much quicker. And then when you get to that 90% and really fine tuning things, bring it back on, and then it's you will get that synchronization. So absolutely, but now it's 3 options that you get to choose from. Excellent question. Thank you. Okay, so now going back to Ultimate Designer. Okay, so let's see how this looks like. Notice that how I got immediate notification, again, about incoming changes. Mike, can I have some drum rolls? Thank you. Now I'm going to click on J1. I can see. Okay, I don't have to accept it if I want. I bring on J2. I'm getting animated view of the proposed location. If I place components here and I reject this, I can send it back. I don't have to accept it. So what I'm going to do, I'm going to push back. I can push back and say, nope, rejecting the change. But I'm going to accept. I'm like, you know what? That's the whole point of collaborating early enough to avoid the point where the electrical has placed 90% of the components and then the mechanical decide to move something. It's like, oh, really? Now I have to reroute and reposition everything. Yeah, no.
Now, say
Yes.
you just want to push half of it back. So you know what? I like the location of J2, but J1 is an interference issue.
Yep.
Can you do that?
Absolutely. Just check the ones you want to accept. By checking this box, check and say only the one with a tick mark, and you accept that's the one that it's going to come in. And then you push the other one back, say, sorry, you know what? Tough luck. No, I played something there. So can you reposition? And they will. So unless those, what I call discrepancies are resolved, the changes will occur on both sides. So for the electrical, it's gonna say, you have that change, and for mechanical, it's gonna try to push back. So you're in each domain, it's gonna show the change. And that's why it's not with this collaboration, we're actually wanted you guys to communicate. It's not, it's there to make you work on your islands. And it's like, no, actually the whole purpose is that we want, you know, interaction. We want a better communication, but we want to reduce friction. So it's still, you have to communicate to your mechanical on what works. This is all can be tracked, but it's really, you know, the value on being able to get to those design intent early enough. I don't have to wait until 90%. Imagine, usually the electrical is like place all his components, he's ready for place and route, he has all the, you know, polygon, and then suddenly, boom, it dropped a hole in the middle of the board. Like, seriously, it would have been nice if I knew about this. So yes, we do communicate holes. Robert mentioned, you know, I asked him earlier, I said, who owns the hole? And he said, it depends. So sometimes the electrical, you know, if it's part of a heat sink, if it's going to be a mounting hole, it can be mechanical. We communicate this information. So if I place a hole here, I'm going to go back to the 2D mode. I'm going to go place a pad to represent the hole. Okay, and I am
also worth reiterating that people came in late, that we're not forcing.
You're looking at me, right?
We're not forcing the electrical domain any changes. We're not sending stroke that all the work is being done in the connector. Force from the tube to the neutral ground.
So on the SolidWorks side, can you see the traces?
not today, not through the connector yet, because this is something that we're considering in 2019 because of two reasons. The way it brings it, it really bogs the SolidWorks mechanical, and it comes into a lump, and it's just mechanics that, hold on a moment, this is not going to work because this is
Using DXF.
yeah. So actually, you can export the way we resolve it today. We export the Parasolid from Altium, and you can export by layer, or you can export the entire copper and bring that and superimpose it over the assembly in SolidWorks Mechanic. And I can show you that one. So that's how we resolve. But this is something that we're definitely considering in 2019 on, you know, people ask, I just want to see copper so I don't drop a hole, or some visual inspection, or, you know, not they're going to run any power network analyzation or thermal yet. Something that we're also considering, but today you just do it through a Parasolid export from Altium and bring that into SolidWorks Mechanical. Yes.
Crazy question. What about flex circuits? Did you address that?
No.
Just rigid?
Today is rigid, yes. So again, we're looking at this whole flex thing, because some customers said we do it through sheet metal. You know, some people say we use Altium to define that. Altium does not have stiffeners. It's just the layer configuration. So we said, we want to drive it right. It's like you have the best two engines here, SolidWorks and Altium. How we can get this piece to be integrated and how we can do it right. And definitely something that R&D is talking about today. And we give them feedback. I give them the requirements. I give them my requirements, at least on what I would like to see. But today it does not. It just flattens. You're absolutely, yes. I didn't say it, maybe earlier. I think maybe early 2020. Yeah, 20, it's too far.
I have a quick question.
Sure.
Is there microphones for our audience that's online to hear us? She's got
She's got
No,
it.
for people on the phone.
questions on the floor.
No, she probably should repeat.
Yeah, if you could please repeat
Oh,
the questions for our people that are-
Absolutely. You're right, because they don't hear. Okay, yeah, thank you. Okay, so I placed a couple of mounting holes, and I'm going to push back. Just, you know, I'm going to say place holes. And I'm going to post. Okay, and now going back to my SolidWorks Mechanical. I get the notification. Okay, I'm going to view them. It's okay, I have PDM, so it wants to do this. I'm just going to accept it all right now. It just wants to check these components. Let's say okay. And then what we're gonna see the two mounting holes coming into SolidWorks Mechanical. And again, you have the sketch for each hole. It's a cut. Okay, we've got holes. And now I can see them in my feature tree. So I can go ahead and open each one and I can resize it. So if I want to resize this one here, again, I'm going to exaggerate a bit. I can resize it. I can place another hole and I can send it over to my electrical counterpart.
What about keep outs?
Excellent. I love it. 2018. We have it now. Yes. Okay. Sorry. Question was, how about keep outs? I got so excited about this. Yes. So how about keep outs? When I showed the mounting hole that we can resize it, the question came, how about keep outs? Yes. And two things that I want to say about keep outs. We have what we call, for the electrical, they know that we have a keep out and a placement barrier. So what we have in 2018 is a placement barrier, component placement barrier that you can define it on X, Y, and Z. So for height restriction and then also on the XY plane, or how far is it from the board edge or how far from the enclosure. You can define this in SolidWorks Mechanical with an envelope, and 2018 allows you to push non-electrical models, so solid model that represent these barriers, heat sink, or enclosure over to the electrical site seamlessly without having them to import a step file. So that's what we support. We don't support the keep outs with respect to traces. So you can give it a name when you define it. I'm going to show this. Are you interested in seeing that, how we define this in mechanical and push it over? Okay, perfect. Yes, we're here until 3. So, Robert, something interested in seeing too, how we define placement barriers? Okay, so what we do, and mechanical people have to ask me, how do you define your barriers today? Placement barrier. If I want to say a component must sit, 100 mil or 1 millimeter away from the board edge, how do you do this today? Is that from the electrical side or from the mechanical side? Yeah, sure. I ask, how do you guys define barriers? Like a keep out for component. I can't have components 1 millimeter away from the board edge. Or, with height restriction, how do you know that in specific area on the board, I cannot have high profile component, anything higher than, 1 millimeter, for example? How do you do this today?
I don't think it is defined by the electrical. Driving that up to mechanical.
It's mechanical. You use crosshatch areas saying from the drawing you use your height restriction.
Yes. So that's exactly how I've received this information. It would be, yes. Thank you for reminding the question. It was, how do you define the keep outs? And I'm sorry? George said it's usually a drawing where we put a crosshatch section and then we send the drawing over to the electrical. And my response was, that's exactly how I received this information, through a drawing, and then I will just take that drawing and place the keep outs on my environment. We define this in SolidWorks today with what we call an envelope. So an envelope, it would be a placement barrier that we add to our assembly, and then we can push this information and communicate this information back to the electrical team without having to initiate a drawing. Every time I talk DXF or drawing, somebody has to massage the data, right? It's like data manipulation, and it just puts goosebumps on me. I'm like, we can't do this, because there's always error for human, errors, always room for human errors. So I'm like, we really want to avoid this. So let me show you how we do this with an envelope. I'm going to add a new part to my subassembly. So again, the beauty of this is your SolidWorks environment. I'm going to go ahead and insert. Let me just rebuild my assembly. I'm going to insert a new part. Okay, that new part is here. I'm going to rename it. Actually, let me save my file first. Okay, I'm saving it internally to that new part. Okay, that's fine. Okay. Okay, I'm gonna rename that part and I'm gonna call it barrier. For example, I'm gonna create a barrier for, edge or top. I'm gonna call barrier top for now. Okay, so that component has been renamed, defined. I'm gonna change that configuration of the part to be an envelope. Okay, and now I am going to edit this part. And I'm going to sketch. Okay. Let me sketch first. Yep, it's just that my,
Select the surface, you should do it.
yeah, right there. Actually, yep, and then I'm gonna offset. And I'm going offset from the board edge, so I'm gonna reverse that. I'm gonna make it 1 millimeter. And extrude pass and offset. Yes, it did. I'm gonna send just a tiny height because Ultim does not accept anything without a height. I don't see it. It's usually, nope, it's not there for some reason. Huh. Let me edit this guy one more time. Okay. Okay, let me. Yeah, I'm converting and then I'm offsetting. So it should, it's because it did not seem to take that offset from the board edge. Usually it will take an offset from the board edge. Let me try it one more time. Nope, it did not take it. So let me just delete this guy. Let me start it one more time. I'm creating an envelope, so, sorry, a sketch from that. So let me sketch one more time. So I'm gonna sketch. Why it's not allowing to?
You're not inside.
I thought oh, okay, let me try again. Here. Okay, so edit part. And then sketch.
Worked on Friday.
It did. Okay, convert entities. Okay, this is better. Okay, I can see now it is perfect. It's there. And then now I'm going to just create an extrusion because in Ultimate Designer, as we know, a 3D body cannot have 0 height. So I'm going to give it tiny, tiny little height, which is 0.001 millimeter. So now I define my placement barrier. And you can see it in SolidWorks Mechanical. And this is an envelope now. And I can go ahead and set my envelope for components that are inside the envelope or crossing selection. So now that this envelope, which I created in SolidWorks Mechanical, and it's used as a placement barrier on the XY, and I can repeat the same thing if I want to create a placement barrier for components on the Z. So meaning that if there is a height restriction, when I bring in the enclosure, some section must have a low profile parts. So I can go ahead and define the same thing, just any polygonal shape, you know, create it, give it some extrusion, and then that will get transported over to the electrical. How does it come over to the electrical? With the collaboration, I'm going to push this over. I'm going to say placement barrier for top, and I'm going to post. Again, today, with the electrical, we have to import the step file. I have to bring in, you know, a step file that represents, you know, a block, or usually it's done through a drawing. I look at the hashed area and then I say, okay, I cannot have, you know, place components, and I end up drawing that keep out myself in the electrical side. So now a new change, I'm going to place it in 3D mode so you guys can see it. And then
Can import like a DXF of that?
the question was, can I import the DXF? Well, that's the whole point. You don't want to import the DXF anymore, right? You can.
Well, I'd say because you just said you have to redraw.
Yes, in Ultimate, if I don't have the connector, I will have to bring in the DXF, and then I will redraw that shape from the DXF. But with the connector, I don't have to, but you still have that option, absolutely. But now I'm like, why do I even want to do it? I can see that I have the 3D body here. And again, this is, I can click and highlight the change. Here is the bodies highlighted. I'm going to go ahead and accept it and apply it. And then now I have the placement barrier in my, let me reset the error markers because it's complaining. You see that I had the error markers complaining because I already have components sitting too close to the board edge. So I can define my component placement rule in Ultimate Designer to bring in the design rule that my components has to sit, you know, 1 millimeter away from the board, from that body, the new 3D body that came. Make sense? Yeah, you notice how it's now actually interfering because the component body, 3D body of that connector colliding with the body of that new barrier. So now I can go to my design rule, and if I simply just select this guy and move it, it's no longer.
A lot of times,
No, that's right. But remember, the restriction came from the mechanical because they placed that barrier there, so they can adjust it with the barrier. Or if that component needs to go, then that barrier doesn't have to go. It can go around just the component. So remember, I just placed it in mechanical. I defined it all around. So if you see here, that was all around. And again, if I run interference and collision in SolidWorks Mechanical, it will, and if I have this as a rule, it will detect it as an interference. But again, the mechanical will say, I'm going to push it, or I need to bring it closer. I'm not going to draw an outline here. Like I said, this can be any polygonal shape that you define. Exactly. I just happen to define it to show that if I do indeed create that, you know, intentionally, then when you look at Ultimate Designer side, when that was sitting too close, let me go ahead here, that was already violating your design component placement rule because it's colliding with the 3D body that represent that placement barrier.
So in the idea, it's within the 3D body? Or
yes, it automatically, no, it's actually, if you look at it, it is a 3D body. So now if I just double click on it, it is a 3D body. It comes in automatically as a 3D body with the name defined to be barrier on the top. So it places it on a mechanical layer and then you view it in 3D. However, it's a locked element. I cannot move because it's been placed by the mechanical. I can unlock. If I try to move that 3D body, it's going to give me a message that it's locked. I can't even, here, this one here, I can't move it because it's a locked object. So that's how we deal with placement barrier. The same exact way we deal also with enclosures. So today, I know it was not in the questions, but maybe somebody from the electrical side, how do you guys deal with enclosures? If you want to bring in, do you have to check components against your enclosure or no?
Mostly we import the step file.
Yes, right?
Yes.
So another thing, we have to import a step file. So the question was, how do you deal with enclosures? And the answer was, we usually import a step file, another interchange format, another file to import. So what we're gonna do in SolidWorks Mechanical, I am going to insert. So I'm going back to my subassembly for the PCB. And what I'm gonna do, I am going to insert the enclosure that represent the top of this part. Actually, I think I have, instead of doing this, it might take quicker just to open first, see if I have it. Yep, here. I'll open. That's the top shell that actually sits on this area. So I'm going, since it's open, I open the file and I'm gonna insert it. Okay. So here's the enclosure. Again, your SolidWorks mechanical environment. You can go ahead and do your typical mates and everything. So let me go ahead and just make a very quick one here. Again, I'm just doing a quick, just alignment. You can, in your mechanical, you do the right mating, the alignment, everything. But that's, pretty good. If I want the mechanical, get it all done and aligned and create all the mates, they send this step over, and then you can go ahead. And you've noticed that I'm dealing with, I didn't have to massage the data. I did not have to save anything out in a different format. This is your environment. This is your trusted tool, and you deal with your native files. Back to Ultimate Designer. Lars, don't leave. This is another good point. There's another drum roll. Yeah. Okay. Oops, I need to charge. So here is, again, I get the flashing nice magenta color for the new enclosure. I'm gonna go ahead and accept and apply. And now I do have the enclosure in my, again, it is, don't worry about these, all the reset I can adjust my rule, but you have a nice representation of the enclosure, the components, the board, and most importantly, I'm in sync with my mechanical person, my mechanical team, not just one person. It's not the one-to-one anymore, it's the one-to-many and many-to-many, because we can control who gets to, work on the design. We have permissions. We can set up all of this. You don't have to worry. That's another thing that we can work with. Who can work on this project and who can collaborate? Yes.
So are those things like on the left, like the comments that you can add it, like notify other people that that's what this is really doing, or whatever is going on?
So the question is, are the commenting on the left-hand side notifying people what to do? Exactly. That's why I said there's still conversation, and we don't want to eliminate that conversation. We want you guys to communicate and elaborate, collaborate, but we want to do it in a much more professional and seamless way. So these are simply, yes, anybody, like your manager would want to come and see the change. At some point, maybe something went wrong, or even not your man, like you guys, the different stakeholders. At some point, you want to revert back. You can look at where the changes happen. You can use, remember, this project is under version control, so I can bring in the storage manager. I can compare between revisions. I can go ahead and revert to an earlier one, because you have all these changes that you're keeping track of, and it gives you the date and time, so you can go ahead and pull your version control manager and compare it, and then look at the changes and compare.
Yeah, that's kind of like Google Docs, where people update documents and kind of highlight things or
Yep.
adding questions or comments.
Exactly. Yes. Yeah. That's how we, and the thing is, it's like the Google Docs, how you guys keep track of changes. Yes, we do it now within your platform, and these changes are like the power of integration with the consistency. The same exact collaboration panel and the history and the changes exist also in the SolidWorks Mechanical. So when I look at this, I get the same exact changes and history in SolidWorks Mechanical as well. Yes.
Good.
So how do the file structures work? I mean, smaller files in servers, so we're mechanical keeps theirs, I don't care. Now it seems like I should care.
Okay, one at a time. So the question was, how does this work? Because electrical keep their file under version control. They don't care about mechanical. I'm just repeating the question. They don't care about mechanical. And then now that we kind of have to care. Yes and no. So the good thing is that with our system, if you have a version control system, so what we do, you can connect to it. So in Ultimate Designer, we come here, and I'll show you through preferences. Oh, I hate 18. They keep changing things on me. Okay, so under Design Repository, Data Management, and your Design Repository. Okay, that default repository is the one that's automatically, remember I said there's that back-end intelligence system called SolidWorks PCB Services that keeps the data linked between SolidWorks Mechanical and Ultimate Designer. Has nothing to do with PDM. This is simply that managed project that you see. This is how we keep the data. And what it comes in, because it has a built-in version control system, it automatically comes with a default repository. If you have an existing repository where you keep all your files, we can go ahead and connect to an existing repository. And we do this by adding it to our SolidWorks PCB services. So we come in here, we create a connection to your existing repository, and then you keep using it the same exact way that you do it today. So if I'm going to create a new project now, notice that with a connector, you're gonna get the option. This is familiar to you, right? Regular or CSV? Yeah, I'm sorry. Yeah, it's okay. So without the connector, what you have in Ultimate Designer, when you create a new project, even from a template, you can create regular or VCS project, right? Version control or regular project. With the connector, you have the option to do managed. So what it does, it makes it available to the mechanical team. And then now, when we add your existing repository, it will become available here. So you can keep pointing to your existing repository to manage your electrical data. And then you have your working local copy for that repository. And I'm using PDM as my working local copy. So I have two safety net. I have my version control system, and I also have the same file, a backup of the file in PDM as well. Right? With any design version control system, you have your vault for that, or repository, excuse me. You have a repository, then you have a working local copy. Your working local copy, I do not know what you use today. Most probably it might be a place on the network or local to your machine. To streamline this and to take advantage and to say, to offer you that level of really the integration between the different, departments, you can use PDM to check in your file and use the working local copy to be a folder in PDM. And that's what exactly I did. When I pulled that project the first time, it automatically checked it into PDM. Again, do you have to do it? Maybe something that you will consider as we progress and you move forward and really structure that workflow. Maybe you start off with a place on your network, and then if you guys are ready for that step to take your files to PDM, then you can do that. Again, we're not imposing anything, but we're saying why SolidWorks, why our ecosystem, because you guys are going to see more and more integration to the SolidWorks ecosystem.
That's my only. How this really.
The question, sorry, let me repeat the question. The question was, how is this going to work with the Google security? So I think this is going to be another discussion that we're going to have. Yeah. Perfect. Monty, you had a question.
No,
You're good? Okay.
She also wanted to demonstrate that we do kind of eat our own dog food, right? So you have these tools available, use them. There doesn't need to be a special integration for it out of the box, right? You're using it out.
Yes.
Okay.
Yes.
So basically, it's kind of like you putting.
I need to, otherwise it's going to die on all of us. Sorry, just 1 second. Okay, this is not picking up. I do not know. Is there? Yeah, this one is not picking up from here. Thank you. Okay, perfect. I'm sorry, what was your question?
So basically, you kind of put in, let's say, all the PCB files in one folder on the network, and all the hardware in another folder on the network, so it's kind of all being backed up and somehow integrated together through this connector tool. Does this sound kind of about right?
Can you repeat that one more time?
So let's say you put most of the PCB files in one folder, and then you put the hardware stuff in another folder, and this connector tool integrate them together and just kind of connect them and make sure how they all work.
Correct. So yes, that's right. So it's not really a question, it's more of a statement that you put your PCB files in one place, you put your mechanical files in one place, and the connector integrates them together. Exactly. It's not going to automatically integrate them. Again, you are using with the connector, it's actually offer you another way to make sure that you can bring those files together. So mechanical PDM, that's fine. Electrical SVN, the repository, that's fine. But now we're saying, you know what? These data, because of that managed environment, the project has to be managed in order to communicate between SolidWorks and Ultim. And what we're going to do, we're going to bring that project, the project is going to be managed, the managed project, and the files can now also be checked in PDM as a second level of, backup. I can hear your headgears, Robert, on how we're going to manage this data. But again, like I said, if you want to keep it local, that's fine. For your working copy, that's okay. You want to take them to PDM, something to consider, because again, that's the whole point, that we're going to at least offer that shared. One of the challenges that we talked about and I presented is that we don't have a shared place, right? There's not a centralized location. Maybe it's not your case. Maybe it's fine. You guys are okay having the different places for a different, design. That's okay. But we're saying it's possible. You don't have to buy another solution. We can offer, you can leverage PDM capabilities. Yes.
The PDM change. ECO, that you were talking about, that. Let me check in, check out. Official ECO.
Correct. So the question was with respect to PDM, with that, ECO, the back and forth, the check-in and check-out, there's not a workflow. And I said yes. The collaboration, the track changes, that happens on the services. That what I said, the back-end intelligence system that has nothing to do with PDM. So even if you don't have PDM today, you can still use that solution because that's being held or being controlled in the intelligent services. But what we're doing, like I said, as you see the progression and how we're bringing things tighter, we are going to offer ways to bring this information to PDM too. You can start a workflow in PDM and you can track those changes. That might become also a way to have a tighter integration to PDM, but still giving you the flexibility. But to answer your question, yes, today, this is, this check-in, check-out has nothing to do with PDM. Today is only the file management for the electrical data, and the mechanical that can all be done in PDM.
Got a question on,
Sure.
on holes. Plated through and non-plated through.
Yes.
They actually have standardized holes, M3 clearance holes that actually have bouts for.
Yes.
Will you be able to see the keep out on SolidWorks side?
Okay, question was with holes. There are M3s and holes with keep out, and would we be able to see that on the SolidWorks side, right? SolidWorks side, yes, you'll be able to see it. Problem is that when you push this information over to the electrical, will they see that keep outs? Today, no. Considering it in the future, yes. So it's just gonna come in as a whole.
This is coming in as a whole.
Yeah. Okay, question was earlier also, how do we see copper? So we can see copper by actually coming to Ultim Designer, and that's the only thing, okay, that's the only thing that we have to do by exporting. And again, today it's exporting the Parasolid file. So by coming here and then I export the Parasolid, and I can export when I see here. I don't have any copper information now, but let me just, I can export by layer. So I can export top, I can export all copper, and then what it will do, it will, you can bring in this info. Actually, let me add some copper data. Actually, let me go back here. I want to show you very quickly. Okay, I don't have to do the whole thing, just something to show traces. I'm gonna export Parasolid. I'm gonna do copper. So what we're gonna do, because this whole board has been collaborated to SolidWorks Mechanical, what I can do now is I can, actually, let me just hide this guy right now. I'm not hiding, changing, just. So what I can do is I can bring in oh, actually, let me open it first. Easier on my machine. I'll open that Parasolid. Where I saved it. my Parasolid file right here. Mhm. Okay, so you can see bringing Parasolid, I can see, because I exported bodies 3D, but I can just hide the 3D bodies and just bring copper if I want it. And then now what I can do is I can bring in that Parasolid file. Is this one of the things that I'm experiencing today? Oh, then we'll do it here. It's actually the other way around. Okay, so here I can just drop it and then I can line it up. And then you can see copper. And so I have one file, which is the subassembly that is linked to the PCB. And then I have the Parasolid, which represent the copper. I bring those two together. And then now I can have a view and I see my copper and I see my components, the live linked assembly to my PCB. So if any changes occur, it will reflect immediately here if I accept those changes.
So those traces are static, or
they're static because it's a export. Yeah, so that's the one thing we still do it static, but we're working on bringing this information through the connector, in future releases. Yeah.
So you just re-export it.
Yeah. So the question was, we have to re-export every time. And if the Parasolid is a static representation, and I said, yes, it is a static representation at the moment because it's done through a Parasolid export, but we're considering this in the future to have copper coming through. And silkscreen, also you've noticed that we don't have the silkscreen information. We can do it there are some, techniques that I've already created. We can bring it as take a screenshot, bring it in as a decal, or we can do an export also from Altium Designer and bring it into SolidWorks. But again, it would be more of a static representation at the moment.
does Altium have a viewer?
Does Altium have a viewer for Altium or for SolidWorks?
For mechanical. Say if I wanted to take a look at the PCB, want to see internal layers or things like that.
Yes. Altium Designer, to answer your question, yes. Altium Designer has a viewer. For the question is, does Altium Designer have a viewer if the mechanical wants to look at the layer stack and see the copper and dive in through the layers? Yes, it does have a viewer. Yep, and you can download it from the website. Perfect. So one thing that I'm also excited to say, part of the process that I said is data management. So we talked about how we can get now, because of the managed environment, we can bring in our data to PDM. So that's one possible way today that you can do, or you can keep using your same process. And then with respect to design synchronization and supply chain, you guys have, your engineering change order built in Altium Designer to import, between the schematic capture and PCB. You might have the unified components. You have your supplier link data. And then last thing is release and the release process. Altium has great features on, from their side on how to release this data. However, not here to talk about what Altium has. I'm here to talk about what we have and what, in addition to having that collaboration, what we're offering you from SolidWorks. Now that you have the PCB, so if we look at this thing here, unfortunately, it's not just didn't do a great job, but you can see. Okay, I have the PCB, and I apologize, it's not maybe shown, but you can see the traces here. So there is the PCB, there is the enclosure, you have the components. That assembly that represents the PCB is linked to your live PCB. So I get a representation, 100% representation of the board shape, the components from the electrical side. I can generate some additional documentation from SolidWorks. So I can do that because this is a live link. So you still need to generate your fabrication and manufacture from, the Ultimate Designer. This is normal. Your Gerbers, your NC drill, your pick and place. But again, think of workflow. Think of maybe we leverage what the tool does best. Maybe SolidWorks will be better to drive some of the documentation that are poorly generated in my ECAD software. Maybe, because now I can come here. I have copper, I have my holes, I have my components. I can go ahead and make the drawing from the assembly. Have all of these great things, given that it's PDM and the default template for drawing. Okay, I can drop this. I can change the view. And again, this is here. Okay, your SolidWorks environment. I can even add bill of material and my bill of material, because this information has been collaborated. Okay, let me actually. Yep. Because now we're not talking with step. We're not talking with dumb data that represent the PCB now. Parameters will come because now I have a true representation of those components and the board in SolidWorks Mechanical. I can pull parameters as well. That's an option that you can enable to pull parameters. So I can have also a BOM available as a choice. In your environment, I can include my components. I can include PCBA. If you just include it as a line item, I can run in and this is your SolidWorks environment. You can customize your BOM as you want. Look at this. This is beautiful. This is a lot of information that we miss. We do not have in any ECAD tool, you cannot get to that precise documentation. I have to create a lot of, I have to do a lot of tricks on the other end in order to bring the 3D, to impose it and then make it everything on one page. Usually it would be the multiple pages to just represent this information. While here I've done it with 3 clicks. So enhancing documentation, maybe talking to your engineering team, electrical, and say, you know what, we might find a way to actually take some of the tedious tasks that you have today on generating documentation and bring it over to the SolidWorks Mechanical, because we have a really great tool that will allow you to do this seamlessly and a much more seamless way. Is that a good thing? I see a lot of heads nodding. They like it, so. Again, this whole reason I'm here is to tell you there is hope, right? There is light at the end of the tunnel. You're not the only one that is, suffering from the disconnect between the tools, and, we have to deal with this data. We're here to help. We're looking at this seriously. And like I said, we are trying to see how we can leverage what we do best to help the electrical engineering community. Yes.
So is this like an add-in, or is it something that like maybe somebody else has to learn new tools because they need to have to integrate all this stuff, or is it something that maybe it's like I think I'm just like maybe thinking from the electrical perspective that this is something they have to learn, this is something new, they have to integrate these things together somehow. So it's a new tool that they have to learn when they're I have to learn this to kind of integrate that. It just seems to make it more complicated in some sense.
Okay, so the question was, is this, with respect to this, is this like an add-in? From the electrical perspective, it seems like we have to learn all of this stuff to get, to know how to use it, or, with respect to, from the electrical, I have to do a lot of things to get it to work. Actually, no. This is what you've seen today is what you're going to get. That's pretty much it. Exactly. The only thing that you need to learn is really the push and pull. And that is it. How you are going to use it. This is not you. This is going to be everybody in this room and everybody who dialed in, because it's more on how you want to implement it. What's the workflow? What's going to make sense? How are we going to control the data? Like I said, you don't need to learn SolidWorks to do this, because the mechanical can help you generate additional documentation that it might take you a lot of time. Not necessarily. It's again, if they have to create, this is up to the mechanic. Maybe we have the mechanical people here to say, is this more work for you guys?
Less work.
It's less work. So that's why we're looking at it. I'm like, the fact that you have a true representation of the data of the PCB, and when we talk PCB data, there is a lot of data. I'm like, just alone on the electrical side, schematic PCB, and then your documentation, and then at the mechanical, remember what I said, the first picture I showed, the arm where everything is coming together, really the mechanical where all of those pieces comes together, right? It's like, it really happens on the mechanical side. They're going to run the bill of materials. They're going to have all of their environment will pull all of these different things together. Maybe not for software, but at least electrical and the mechanical. That's why we call it the mechatronics,
So, I mean,
right?
Like from a theoretical perspective, this seems to streamlining things, but at the same time, there's still like maybe things that haven't really been ironed out in some ways. Like Anthony was saying, how there's the copper or whatever doesn't show up, or the whatever doesn't show up yet in some sense.
Yeah.
And so is this missing items, and also,
So the question was, it seems like it streamlined some of the flow, but there are things that are still missing. Absolutely, like what Anthony said, the keep out around the hole or the copper. Absolutely. But keep in mind, this stuff we are working on it. So you are going to see, like any other software, we released the software about a year ago. So just from the year, and maybe Mike and Bruce can witness that, from the progression, that from 17 to 18, a lot of features. Actually, we nailed down all the errors, between like all these errors and access violation between the tools. Actually, we knocked all of these out. The focus on 2019 is going to be a big leap. It's maybe jump. I call it a jump because you're going to see a lot of we're constantly adding features to the collaboration. Like I said, by next year, you're going to see copper. By next year, you're going to see silk screen. By next year, you're going to see patterns and holes and all of this stuff, because we're understanding more and more the mechanical environment.
So is there any user testing or?
Absolutely. Yes. The question was, is there any user testing or test cases? Mike? We have
I'm sure
I'm sorry? Josh, our product manager, released some. We can definitely share those with you. And, they've been successful with the connectors. So absolutely something that we can make available to you. I'm here, like I said, because we're understanding more and more the mechanical side. And as Anthony said, M3s, patterns, and things like this. We're like, oh, yeah, these are the stuff that we did not take in consideration. How is it done? What's the workflow? How the mechanical defines it? You will see more and more enhancement and more tighter integration, and even as more and more seamless workflow.
Many moons ago, I worked for Vision, so that we came out to the cadences of the world and said, wouldn't it be great if you worked with people? And they just said, BS, it slows us down, it's too data heavy, get out of here. And Altium was able to do it visually, so you can see it's not manufactured in 3D, but it's polygonal.
That's right.
Visualization. So you can take these clearance checks. But what this offers is what I've always been taught is if you're making a product that you want to stay platform and not have a bunch of different stuff moving around, neutral files in and out, because it'll clobber something else downstream. It'll create a headache. Like step files, I just never came up with this thing.
No.
You know, if they were wise enough at least not to have that option, because you would have even another universe, another messy universe to deal with. So what this connector is trying to do, what we're trying to do, is reconcile the platform so that things go a lot smoother. You don't have to struggle with the data massaging. I don't have to massage the Excel because I'm on the platform. I got the article format that for the SolidWorks community. Hopefully that benefits.
We're barely scratching that surface. Yes.
I don't know if that made sense. Yeah.
Okay, perfect. I think Anthony had a question.
Yeah,
Right?
so my question is, so after layout's done, and now we have traces, and there are traces that are moving and things like that. You're not using the push and pull out that method, right?
So the question,
That's invisible.
yes, the
That's
question,
not gonna come across saying,
yes.
I moved internal traces.
Correct. So the question was, once we're done with the layout and we push traces and traces are moving, that's right, because traces are not being collaborated. And again, if that's going to come in the future as an option to you, it would be not a dynamic. It's not like you're, imagine with traces and copper information, do you really want to see this? No, it would be also an option off and on. Do you want to bring it or you don't want to bring it? So that's, yes, but today you're not going to see it. You're only going to see your components, your board shape, your mounting holes, and all of this information that you care most to just continue on with your mechanical design. And then when the electrical are done with everything, you know, with placement should be done early, but with routing, they can just export the parasolid, bring it in, so you just impose it and make just run a visual inspection.
So in regards to exposing copper,
Yes.
say for instance, I have a heat sink, now I need to ground it, I need some grounding springs.
Yep.
Or I need to touch the board to make sure it's grounded.
Yes.
Is that done on mechanical part and then pushed over, or is that coming from?
Up to you. So heatsink, remember, now we can bring, like how we brought the enclosure and the placement barrier, a heatsink is a part in the mechanical. You can bring that heatsink, add your heatsink to the PCB and push it over. And then Robert can define, you know, the holes, where it goes, how it needs to, you know, he's not gonna move it, because if it needs to go somewhere, then he's just gonna say, okay, I'm gonna drop the holes here, I'm gonna do my stitching via, or my vias that needs to go, you know, there, and push it back over to you. So again, it's up to, does he want to place it as a 3D body in his environment first and then push it over to you? Again, yes, it's possible. It's up to you on who, like I said, my question went back to who owns the whole, who wants to collaborate this information, but it's completely up to you on whether on the mechanical and we push it, or let this electrical place it and bring it over and then we move it. Up to you. Yes. Exactly. That's something that you guys will define. Yes, makes sense more on the schematic side, that you will place it there, push it over. Information over to you. Oh. I do not know. It just, is it trying like to kick us out? Maybe because it. The question was, is this part of the 3D experience? No, not. No, it will require a special implementation to get it on the 3D platform. So we have somebody internally that I think that's so acquired, Patrick, who developed the connector for all team, that most were talking to our product management to see if this is something that we're considering in the future to be on the 3D platform. But today it's not.
I know one thing that I've seen is that
There is. Just want to clarify, is more experience
Yes.
One thing I've seen is that, so I have a design that's released as far as the PCB side and the mechanical side. But then the PCB team comes in and start making some changes that don't really impact the mechanical design, but keep my model current. Now, I'd like to have the latest revision. Do I get flagged, or is there some type of notification?
If
saying-
it's,
that-
okay,
that, hey, this is impacted, you are the owner of this file, or it's been released, it needs to be notified? Is there?
okay, so the question was, PCB is done, mechanical is done, electrical go back, and they make some changes to the PCB that do not affect mechanical. Is there a way to get notification or flag? Again, up to you. How early did you collaborate? So I am done with PCB, and then I decided, actually I decided to push the board in SolidWorks mechanical. So this is what I've done actually for a customer the other day. They said, they put me on the spot, and Mike was there. Angie, we want to see a completed board. We're not going to start from the beginning, but show me how quickly would it take to bring, that's the MIMO design completed. And they said, pretend that it's completed, it's done, and I have the mechanical side. Took me 3 minutes to push from Ultim and 3 minutes to pull from SolidWorks, and it built this beautiful board. That's, yeah, not going to do it. Yeah, I have the video that I can share with you. But again, the nice thing about it, look at this. You see the collaboration. I did not pull again. I pulled the first time to build it, and it took 3 minutes. The second time I push and pull, literally, it's just seconds. So the subsequent push and pull, they're seconds. But because I collaborate, you can forget about it, and you can even fabricate it. The history, and realize that I just didn't open. I just opened the file. It kept history with all of this. So if there are changes to something that you forgot about, and the moment you're going to open it, and there are changes with respect to board outline components or holes, they're going to be available to you. And you're going to say, oh, great, because we collaborated. We push even a completed board, which at some point it came in all completed, done, but somebody makes changes. And you can see I have some changes here that I've done, maybe a couple of weeks later. I open and I see the notification. So even with completed design, you can bring it in immediately to your SolidWorks environment just to make sure that, yes, everything is great, we're synchronized, there are no changes. Month later, you come and open the part, boom, I see changes. Answer your question, Moni? Perfect, thank you.
Got a quick question. Where does the 3D representations of the components come from?
Okay, the question was, where's the 3D representation of the components come from? It comes from what we embed in Ultim Designer. So today, it is driven from the electrical side. So in Ultim Designer, when we create a footprint, we embed a representation of the model. With the connector today, and earlier before you came, I talked that what you gain with a connector is that you can embed native solid part or parasolid. That helps with the file size and Ultim Designer of the PCB, because with step, things tends to get larger. So now you can go into the footprint and embed solid part, SLDPRT, or parasolid, or continue with your step file or generic modes, generic shapes, which is geometry with some extrusion, and then those will come across. Depends on what type of precision and granularity you want to, see on the mechanical side. Usually, like if you have resistors and caps that are modeled with generic shapes, that's fine, and you don't want to represent them with more, intricate parts, you're okay. Maybe connectors and LCDs, push buttons, LEDs, you want to have a solid model where you have the nice details from the SolidWorks mechanical. Send it over, he's going to embed that part, boom, push it over, you have it. And you get what you see on the screen here, where I have the nice, like this one here, it's a part. Let's see if I have some components. I think I represent, this is all. Yeah, this part here, I just left it. That's what you'll get like as, a generic shape in Ultim Designer, some geometry with height, because I care less. But if that's one of the most critical part, maybe I need a nicer representation like this inductor here. That's like very critical because it has a height that I'm going to check against the enclosure. So the mechanical wants to see, that precise model. So we're going to go ahead and embed the solid part, and it's going to build it and come to you in your mechanical environment. We have what? I have a hard stop. I have a flight to catch. much. So, questions? Yes,
So
we have one more question. Yes. Oh, no. it's okay.
stop talking. I can't. So now I have my initial layout, and now the electrical engineer starts adding all these little jelly bean parts. He keeps pushing it in every day. So when I look at my connector tool, is that sequential as I'm looking to pull in, or is it just one?
No, it's gonna be whatever last push. So let's say so sorry. First, the question is: electrical engineer is doing layout, and they keep adding the jelly bean parts, which is resistors and caps, and I like that term, the jelly bean parts. So they keep adding them, and then is that sequential, or I'm gonna get them all in a lump? Okay, so the answer is depends on how when you are working on that on the mechanical side. So he added 4 resistor and push. You're gonna get the notification with 4 resistors. Let's say you're not working on the mechanical, so he added 4 resistors and pushed. Then he added 4 more and then pushed, and then 8 more and pushed. When you open that assembly, you're gonna get all 60. You're gonna get everything compiled that currently compares it to your current status in SolidWorks Mechanical. So the current state of your mechanical assembly will be compared to its correspondent PCB, and all the differences are all gonna show up.
Can I go back and revision of seeing?
Absolutely. We don't do it with the connector yet, but what you'll do is that you can see all the changes that they've made, and then you can trace it to, like in Altium, they have the storage manager. They can see it to when they checked in the file. You can do it in mechanical if you have PDM, then you can see the date and time, and then you can review it and, pull an earlier version. But it will have to be compare the date and time that it was done, and then looking at that file from your own system, version control system. We're not yet into that, connector really allow you to revert back from within, because yet another thing that we're looking at. Yeah. Perfect.
Before you wrap up,
Yes.
maybe you can use the time for your contact information.
Absolutely. So that's excellent.
We have people that live stream in, and you don't see them.
I have. The question, yes, was can you put your live? Okay, right here.
Smile.
Yes. Okay. Right there. So the question was, can you put your information? And actually, I will add. Oops, sorry. Sorry, that was too quick. Let me.
Smile.
Yes, smile. Let me. Because I don't have a card, but Mike and Bruce do, so they can have. I added my email address to the slide as well. So all phone numbers, Bruce, Mike, myself, and my email address, and Bruce and Mike have their cards or info. I'm sure that it's with Monty, and my information is also my contact. Yeah, it's easy. First dot last at 3DS. Yeah. So I want to take the time to thank you all very much for carving out the time. I know it's hard. Thank you. I know it's hard to carve out 2 hours of your busy schedule, but I really appreciate it. You see, the benefit is that we're here to help you, and we're here to listen to your pain, and we're trying to take away some as much as we can. We promise that we'll get there at some point. Maybe not all of the barriers that we tried to knock out today, but definitely some. So thank you again. It was nice meeting you all. Thank you guys over on the phone. Appreciate your help. Thank you.
Thank you.
Thank you, Monty and Lars, for putting all this together.
I'm just going to real quickly, I just want to make sure that, if you have specific